Hello everyone. Today we are going to see a new problem. Obtain a PDA to accept the language that is L of M. So W. So W is the set of strings that is accepted by the machine, and they're saying such that they have a condition W belong to A and B. So we have two set of inputs A and B and N of A in W. So W is the string. Okay, so W is the string the machine can accept as an input. Okay, you can say it as an input string. Okay, n of a means the number of a in the given string should be equal to the number of b. Actually, in the previous session, we have saw a to the power of n and b to the power of n. Actually, this is very similar to the previous question, but one small change in this previous question is it is a to the power of n and b to the power of n. What it says means all the a comes in the first part, then it is followed by the b. Okay, for example, if a to the power of 3 means all the a will come in the first part and all the b will come in the second part. Okay, so even though this both the questions look similar, but they are different. Okay, because the total count may be same, but the order matters a lot. In this one they're saying n of a of w is equal to n of b of w. Here also, if the number of element of a is 3 and the b should also be 3, but it need not to be the same order whatever we did in the previous question. Okay, so you can check in my channel. So we have already uploaded this previous question in the previous days. Okay, so the same question will take a to the power of 3 and b to the power of 3. In this case, we can say the a can come first and the b can come next, so it can be ab ab ab. Okay, but end of the day the number of a is 3 and the number of b is 3. So this is one way. The other way you can get like ab bbb aa. So our main intention is we should have 3 number of a, 3 number of b. Okay, the number of a is equal to number of b, but order does not matter in this question, but whereas is very clearly matches in the previous question. Okay, so both the major logic are same, but we have a little changes whenever you're writing the transition diagram. Okay, I believe you understood the difference. Now we'll directly go into the transition for the given question. Okay, yes, so we start like this. So first transition, so as usual, so we have a empty stack. Okay, so before going to the transitions, we'll quickly see a stack review how exactly it works. Okay, as usual, the empty stack will have a z naught. It denotes empty stack. So whenever we see empty stack, there is no input. We saw the first input, it can be a or b, we'll push into the stack. Okay, and whenever we see the second input, from the second input, one cases it can be a, second cases it can be a b. If a stack is empty, when you saw the b input, you'll push it. Okay, after pushing you see the next a, already the top of the stack is a. If you see the next a, you push that also to the top of the stack. By chance the top of the stack was a and your next input was b, then you pop it. In the same way for b case also, if the first time if you see the b, you push it. Okay, again if you're seeing one more b, already the top of the stack is b, then push it. If not, if you see the a, then pop it. Okay, so this is the way we're going to implement, so that the push and pop is equal. Okay, then the number of a and number of b will be equal. Okay, so we'll see the same logic in a transition diagram. Okay, so the first transition is q naught. So initial state is q naught, a is the input, the top of the stack is z naught. So this goes to, it will be in the same state q naught itself. Okay, and we have a and the top of the stack z, we'll push it. Okay, because the stack is empty, we'll push it for the first launch. Same way for the second case also, it is a q naught and we have a b input and we have a z naught, the top of the stack is z naught. Then also we'll stay in the same state and we'll push it, we'll push the b to the z naught, top of the stack. Okay, so this is the first case. Okay, now we'll do the second case. Second case is whenever you have a and the top of the stack is a, your new input is a and the top of the stack is a. So then what you will do, you will say q naught and we'll push, already the top of the stack was a, you will push this new a to the top of the stack. So that is a comma a. Okay, so it's the second case. If it is the top of the stack is A. Instead of A, we can say top of the stack is B and our input is B. Then also we'll push into the stack, that is B and B. Okay, already it was a B and you're reading a new input also B. So we not found any match of them. We'll push it to the stack. Okay, this is second case. Now we'll see the third case. That is Q naught. We have a as an input, but we have a B is the top of the stack. Then you want to do the epsilon. Okay, yeah. And one more, the difference between the previous sum and this one. So here what happened, whenever we have a to the power of n, we use the push logic. For b of n, we use the pop logic. Okay, but here in this case we can't do like that. So it will, all the transition will stay in the same state unless until the stack going to become empty and go into a final state. Okay, so next again we'll say Q naught on other combination. The B is the input, the top of the stack is A. Then also you will do epsilon, that is pop operation. Okay, after all this, there is no more element in the Q naught. That is, the new input is epsilon and the top of the stack is Z naught. Then we go to the final state Q1 and the stack of the stack is empty. Okay, so again here we have only two transitions. Okay, so that is q0 and q1. Okay, we'll draw the transition diagram. So we have a q0. Okay, we'll make it as a first state, and we have a q1, that is this final state. So we'll mark it as a double circle because it's a final state. So that is q1, and we'll write this transition. So from q0 to q1, what was the transition? Epsilon z0 is the input, epsilon comma z0 is the input, such that the output is z0. It will retain the z0 as it is. So remaining all this transition, it is going from q0 to q0 itself. So we'll draw a self loop for the q0 and list all the transition states. So we'll start from this one. So that is a comma z0 will change to a z0. Same way b comma z0 will change as b z0, push the stack. Same way here a comma a. Okay, that is a comma a will become a. Same way b comma b will become bb. Same way a comma b will become epsilon. Then b comma a will become epsilon. Okay, yeah. And as much as possible you write this transition in the top of it. Due to this page restriction I'm writing here, because whenever you write here it may believed as this transition, so that whenever you're writing the states you write it here. Okay. Thank you for watching. Please subscribe and like and comment for more such videos. Thank you.